Good morning, my super friends! Thank you for coming along. I think I sound far more animated than I actually feel, but that's usually the way. I try to sound animated. So, just before we get into other things, my Aboriginal awareness shout out for today is the Aboriginal Advancement League, which was founded in the 1960s originally by a group of white people, but it fairly quickly transitioned into being run by Aboriginal Australians. So it now runs a whole lot of different programs for maintaining, preserving Aboriginal culture. So that is a cool thing to check out. How excited are you? Yeah. So, good morning everybody. Who have we got here? So, Mr. X, Mr. Y. Someone is into coordinates. I'll get back to your question in just a second. G'day Andy, Sion. Johnny's here. Peter Lawler. Oh, some call it fun. Some call it fun. I don't know if that is someone that I know by another name. Thanks for coming along. Ilix is here. Yes, happy Pi Day. So, alright, I do have a few things to talk about today. There is one thing that is potentially really important, and I don't know if I'm going to get to it. It might justify an entire squirrel chasing session of its own. Oh, Aaron, g'day, thanks for coming along. And Raspberry. Alright, so I'm just briefly going to get back to Mr. X, Mr. Y's question right at the start. So the question was, I just watched Superhouse number 41 again. So for reference, that was the second most recent one, which was about data logging with InfluxDB, MQTT, all that sort of thing, Grafana. And I have some questions. Can sensors publish to multiple brokers? And what does InfluxDB do when the disk gets full? Okay. Question part the first. Can sensors publish to multiple brokers? Yes. That is totally up to the client. What you can do is make connections to multiple brokers. Depending on the client library, you may not be able to have multiple instances of the MQTT object in your code. So this is going to depend on how the library is implemented, how the client side is implemented in your device, like in your sensor or whatever it is. So what you could do is two options. If you are using a library that creates an object for the client that allows you to connect to the broker, you may be able to instantiate multiple objects and have them connected to different brokers simultaneously and maintain those connections, and then you can publish to them independently, or you could publish the same message to both of them. The alternative, if your code or your library does not support that, is to make a connection to a broker, publish to it, disconnect, connect to a different broker, publish to it, and disconnect, which is a bit of a pain, but you could certainly do it. The fundamental question below this, I thought I was going to be answering this question in 30 seconds, and now I'm chasing squirrels already. So the fundamental question below this is what you're trying to achieve. Why you would have a device or a client that publishes to multiple MQTT brokers. Now, I can certainly imagine circumstances where that would be happening. For example, in the specific case of something like an air quality sensor, there might be a situation where you're running your own local MQTT broker, you're using InfluxDB and Grafana, you're doing all your local charting like I showed in episode 41, but you also want to send your data to some other centralized service like the open air quality, I can't remember what it's called, the air quality service that is running out of Germany, where they collect data from sensors all over the world and then provide aggregated reporting so you can see air quality across your area. And I think they provide an MQTT interface, not just a regular HTTP API. So in that situation, you might want your device to publish to your local broker and also publish to some other broker. And that is certainly a legitimate thing to want to do. Another way to do that would be to, if your client can't be modified, it can only publish to one broker, it's relatively easy to write a script that acts as a bridge and it republishes. So what you would do in that situation is have your, maybe I should draw diagrams. I should get out a bit of paper and use the overhead camera. So what you would do is have your client publish to your local MQTT broker. And that's all it needs to do. It doesn't need to understand anything else. Then what you can do is have a client that is just a script. It could be a piece of Python or something like that, which is subscribed to the same topic, and it sees the message and then it republishes it to a different broker. And that is also a perfectly legitimate way of doing it. And that way what you can do is have your bridge script or your republishing script. You could do things like change the formats, like it could, the way you are taking the data onto your broker might be different to the way the other service requires it to be reported. So you could do format conversions and whatever you need to do. So there are some options there. So Mr. X, Mr. Y, hopefully that is the start of, that partly answers your first question. And the second part of that was, what does InfluxDB do when the disk gets full? The flippant answer to that is it breaks. But what you really want to know is how to avoid that happening. So InfluxDB has a, well, the danger with storing lots of sensor data is that you acquire lots of data points over a period of time. Alright, so typically with something like a temperature sensor or an air quality sensor or whatever, it'll be publishing perhaps every minute, maybe every 5 minutes, you know, it could be more or less frequent, whatever. You're going to have this continuous stream of data. And what you typically care about is if you're looking at data in recent history, you might need detail. You want it to be fairly fine-grained. But if you go back okay, so here's a good example. Let's just look at weather. If we wanted to look at the temperature of today or yesterday, we might want to look at a curve over the course of the day of, you know, what time it reached a certain temperature, etc. So you want that plot of that data. But if you look back at a day 50 years ago, do you want that detailed curve, or do you just want to know the minimum temperature and the maximum temperature? 2 data points, that's it. You don't care about all of the intermediate data points. Or maybe you just want the average temperature for that day. So the amount of data that you want for historical information is typically much less than the data that you want for recent or current data. And the way you can handle that is with data rollup. There are a number of different terms for it. There's data rollup, there's consolidation, and data thinning, or whatever. And the way InfluxDB handles this is with 2 mechanisms. One is called continuous query, and one is called the retention policy. And I'm not going to go into those in great detail right now, partly because I can't, because I don't know enough about it. I know enough to kind of explain it, but not enough to, you know, do a detailed tutorial or anything like that. So continuous queries are a mechanism that is built into the database engine, because InfluxDB is specifically for storing a whole series of data points. It's storing data over a period of time, and it faces exactly this problem of the data store growing linearly with time, which you don't necessarily want. So continuous queries are a way of rolling up many data points into a smaller number of data points. And looking back, for example, you might look at yesterday's temperature data. You don't want to see, excuse me, every 1 minute data point across the course of the day. You might want to see a chart that shows you the temperature at each hour of the day. So with a continuous query, what it does is roll up data within certain time periods and you can get information about it. So you can say, I've got 60 samples across this 1 hour period, but I only want to know what the average was across that 1 hour period and give me one number. And so, yeah, you can do all sorts of useful things like that. And retention policy is about how long it keeps the data. So you can set a duration, so you can say I don't want to keep data older than a certain thing and have it cleared out of the database. You can also do it manually, and this is what I originally did on my InfluxDB system when I was running it on a Raspberry Pi. So when I first started running InfluxDB, it was on a Raspberry Pi on an 8 gig SD card, and I filled that SD card up pretty fast because I was logging lots of stuff. I was recording data from all sorts of things, like if you look at so typically what I do is pull data in using Node-RED and then shove that into InfluxDB. And I was recording things like the battery voltage on every single one of my Zigbee devices every minute, just ridiculous stuff like that. And those batteries are going to last a year. You don't need minute data for that. But what happened was that my InfluxDB directory, the data directory, just kept growing and growing, got out of control. So instead of doing it the proper way, which was using things like retention policy, what I did was write an InfluxDB query and then stick it in a script. So I think I was running it out of a Python script. I can't remember now. It's actually I'm not even running that Raspberry Pi anymore. I've now migrated everything over to using Docker on my Synology NAS. And so what I would do is run this script just off a cron job. I mean, this is classic sysadmin fix it with baling wire sort of thing. Cron job that runs a script that ran an InfluxDB query that found records older than a certain thing. I think it was like older than a month, and it would just delete them. So it was repeatedly pruning off the end of the database so that it wouldn't grow and fill up my disk, which really, really sucked. So if this is a subject that is, I was actually thinking of getting into this in that InfluxDB video, but it ended up quite long already, and I figured that this is a deep enough topic that it needs more focus. So I was thinking of maybe doing a video specifically about continuous queries and retention policies in InfluxDB. But before I do that, I need to learn more about them myself. As I said, I can tell you right now what they are, but in order to actually use them, I'd be Googling like crazy and trying to figure things out as I go. So trying to explain them and not be telling you the wrong thing, I'd have to be more careful about that. Alrighty, so where are we up to? Okay, let's see. So I'm expecting some comments from Bridges. Okay. So this is getting back to the MQTT thing. I saw a couple of comments, so I'm just going to bring these up. I'm going to mention them. Sorry, moving stuff around on my screen. So Aaron said you can set up an MQTT broker bridge. It's supported with Mosquito 2. Yeah, cool. So a broker bridge is what it sounds like. It's a link between brokers. And Andrew Gordon also said, use bridges. I have a central broker. One of my devices has its own broker for local control, but the broker also bridges to the central. What is going on? Oh, hang on. I just activated. No, I do not want to use voice activation on the tablet. How do I get out of that? Get out of there. That's better. Oh, some call it fun. 3.14 US dollars. Thank you. I wonder if I can buy a pie for that. Probably. What's in a pie? Don't really feel like a meat pie today. What I feel like is maybe like an apple and blueberry pie. You know, some combination sweet pie like that would be nice. Yeah, so yes, so both Aaron and Andrew say use bridges. So Andrew said Central Broker also bridges to TTN, which is the Things Network, to get data from those sensors. Yep. Okay. Okay, so Dodgy, this is regarding like data aggregation. Dodgy said that suggests that it would have to delete the other 59 points during that hour. Yes, it can. So what you can do is take the average of, say you've in your database, oh Peter, that's an Australian 3.14, that's a 3.14 Aussie bucks or Kanga bucks. Thanks Peter. What you can do is take, say you've got 60 data points across a 1 hour period, so 1 minute data. What you can do is calculate the average of those and delete all the data points and replace them with a single data point, which is the average for that hour. And that way, essentially, you are thinning your data or compressing your data. You're losing resolution. It's like, you know, JPEG image compression. It's a lossy compression algorithm. You can't undo it to get all the data back again, but that's the price you pay for not having to store every single piece of data along the way. Yeah. So, Aaron also suggested proactively archive and or push to cold storage for older data. Yeah, that's a good thing as well. So, and related to that, Aaron also said, also maybe only store data if a value changes from the last saved value. That can save a lot of space too. That is absolutely true. Yes, only save changes. Now that, depending on how you are charting it, that can cause problems. Most of the time it's fine, but I just raised this as a thing to be aware of. So you can implement this either on the client side, or you could do it on the broker, like if you had some kind of an intermediary script, or you could do it in the database. So in the database, well, in any of those, the general concept is you took a reading and it was 22.3 degrees, and then 1 minute later you take another reading and it's 22.3 degrees, so you just don't bother sending the data. Whatever the last data point was is still correct. It hasn't been invalidated, so don't send it. There are issues with that potentially, with things like averaging algorithms depending on how they work. If you're assuming that a value applies to a certain time slice, like a 60-second interval, and then you've got no data for the next 60-second interval, then that can screw up some averaging, potentially. But most of the time it's okay. Oh, Bob P, more pie. It is a very pie day today. But yes, Aaron's point is very important. Also, maybe store data if value changes from the last. I'm trying to think of a way that I've implemented that. I don't think I did anything like that in the air quality sensor firmware. Oh no, I don't think I did. But I've definitely used that technique in some other projects where you have the you store it. I'm talking about on the client side. So you have a variable, so just set a global variable for the last reported value, and then when you read your sensor again, you compare it to the last reported value and only report if it's different. and that can save a lot of data. But the other point that Aaron made about proactively archiving is also a good one. And this is something that's often done. Okay, so we could be getting deep into database concepts here. There's a kind of related but not the same concept called sharding, which is used in large databases, where you have a large data set and it is slow to work with, or you've got storage restrictions. So you slice the data, essentially you slice it, depends which way you look at the table, but you store some data in one location and some in another. Now, sharding is typically used for performance reasons when you might want to be able to do things like have half of your data stored on one server, one on another, and you run the same query on both servers simultaneously, and you get the results back and aggregate them, and effectively you've doubled your performance because each one is only having to query half the data set. Now, it's actually much more complicated than that because there are issues with indexing, and the way you handle sharding is usually by splitting on some kind of an index. So you have an index range on one server and an index range on another server. Anyway, this is actually the sort of thing that I spent many years of my life working on, so I could chase this squirrel all day, but I'm not going to. I'm going to try. That's the life I've been trying to put behind me. Aaron's point was archive cold data, which is data that you're not necessarily going to be querying. And that's different to sharding in terms of what I was just describing. So sharding is when you have live data and you split it to be able to query it more quickly by segmenting the data set. Putting data into cold storage is when you have data that you want to be able to query and get immediate results from it, and essentially have like an archive where it might be a second database with the same structure, but you don't typically use it. So what you do is you have a query that will occasionally pull the oldest data out of your live database and shove it into your archive database. So your archive database will grow over time, your live database won't. It'll grow to a certain size and then just stay there because the number of data points won't increase over time. So Ben said, I've missed some of the intro and context. Delta V has concepts of exception and compression to minimize data volume. Yeah. Yes, and Aaron made a comment. This is what I was getting at earlier. Our client charts expect a data point at certain intervals. If the DB has missing interval values, it automatically fills in the data points with the previous data value. We have this for averaging too. Yeah, cool. So that's where I was saying that if your reporting system expects data for known specific intervals for averaging purposes or charting or whatever, and you don't send data because it hasn't changed, then things get screwed up. But you can compensate for that in the reporting system and have it just assume the value hasn't changed. So that is certainly a very valid way of doing it. And as long as the different parts of the system, so the part that is acquiring the data and reporting it, acquiring the data and then it's being stored, and then the part that's reporting it knows that you can't rely on there being a data point at every regular interval, and it can account for that, then fantastic, it all works. Very nice. No, I did not say sharding, I said sharding. I should make it with a hard D, DDD, shard, as in to split it into pieces. Yes. All right. Oh, in the old world, Mr. X, Mr. Y said it may be Pi Day down under, but not here in the old world. Not yet, anyway. Oldie worldy. Are you where are you? If you're old world, maybe England, but that would be, so we're at GMT plus 11. It would be heading towards midnight in GMT, I think, at the moment. Okay. So Ben elaborated on his comment earlier, which was an exception means the sensor only transmitting when values change enough or a certain amount of time passes. Yeah, that's the other important point. If you have code that says my value hasn't changed, so I'm not going to report, as a safety thing, what you should do is have a sorry, something just fell off my monitor while I was talking. What you should also do is have in your code know when the last time you reported was, and then after a certain number of cycles or period of time or whatever has passed, you report anyway, even if the value hasn't changed. That can be useful for a heartbeat sort of thing, like the fact that you know the sensor is still alive. Now, if the value hasn't changed for a long period of time and the sensor hasn't reported because of that, then you might start thinking, my sensor's dead. And your monitoring system, like your service health monitoring system, might say, you've got a problem with this sensor. It hasn't checked in for 17 minutes and it's meant to check in every minute and raise an alert, when in fact it was just that the value hadn't changed, so it didn't bother reporting. So having some kind of a timeout where it's going to report every minute, unless the value hasn't changed. So if the value hasn't changed, it doesn't report. But then if it hasn't reported for 10 minutes, then report anyway. You know, some logic like that. Anyway, you're all smart. You can figure it out. Right. Okay. Yes. Yeah. Oh, Brian. Oh, Brian. Hey. Thanks for coming along, Brian. So Brian said, I imagine a problem with not recording changes is it then becomes difficult to distinguish if there are no new readings because there was no change or no new readings because the sensor went offline. Exactly. Yes. In fact, I think you typed that comment before I just said what I just said. Okay. Yeah, so Ben, sounds like Ben has some good experience with this stuff. Ben said, hot and cold storage can also be hot, warm, cold if you also use RAM. Query in-memory values for displays and alert monitoring, near data for recent trends, and spinning Rust for archive. Yep. I think Ben's done this before. What's the term? You've seen this movie before. Yes. And yes. Peter. Hey, good morning, Peter. Thanks for coming along. All right. So, Aaron said, logic handles this as if cross-referenced a log to determine if sensor was offline before backfill data values are unchanged from previous. We have 12 million data points a month to handle. Aaron, sounds like you're dealing with some kind of serious scale there. But then there are other people that are here that'll say, 12 million data points? Poof, I do that before breakfast. There are all sorts of scales. So, you know, when I started reading the comments, I thought, I'll just quickly answer this first one because it's easy, it'll take a minute. And here we are, it's 10:30, and I'm still talking about it. Okay. So, there are two other topics that I had in mind. And of course there are an infinite number of squirrels, given that, as Andy pointed out, we could chase one squirrel for every digit in pi, and we might discover new digits of pi. I think we might have exceeded the number of digits of pi already. So, cool. So this explains some of Ben's experience with this. Ben said, worked in biopharma, was interested in SCADA controls. then went to a tech company, so hot, warm, cold is cost, latency, trade-offs. All subjects that are super interesting. Yeah, they are. They are, which is why I keep talking about them. I actually really love playing with databases. But as I said, I've spent many, many years of my life doing that. Which many of you would know already, because that's primarily what IVT did. It was dealing with lots of data and databases, and I even worked for MariaDB Foundation for a little while, which I haven't really. I've mentioned that once or twice, I think, on live streams, but after IVT, I contracted, and I've talked about going to Finland a couple of times, and ending up in Tallinn in Estonia after hanging out at Monty's place in Helsinki, or just outside Helsinki. So Monty is the original creator, one of the two original creators of MySQL, and then MariaDB, the fork of it. So while I was working for MariaDB, I got to go and hang out at his house in Finland, which was really cool. Anyway, that's another squirrel I won't chase right now. So, there was another squirrel just dangled in front of my nose a minute ago, which was Austin's Creations. Said, how's the robot arm coming along? All right, let's chase this squirrel for a moment. The robot arm so what Austin would be talking about is the InfluxDB robot arm that Naomi Wu sent over for me to work on with Chris, and we've got that connected. Did I show? I think on Twitter I showed a video with the arm moving. So what we've got is the robot arm set up. In fact, let's see if I'm gonna see if I can find the video for it. I find it hard to multitask. My brain just does not multitask very well. So while I'm doing one thing like searching for something, I can't really talk about a totally different subject. But what I'm just going to do is try to find the video that I posted on... Where did I post it? I think I posted it on Twitter? Somewhere. There's the arm. Where did it go? Oh, I think I know. I think I moved the video. I did. Because I have different directories for different projects. Something that is definitely a squirrel that I would like to chase sometime, but not now, is how to organize. In fact, I think I've talked about this a little bit in the past, but it warrants an update. How to organize data and design files and all those sorts of things for projects that you work on. How do you store it? How do you, where do you keep your hardware CAD versus firmware versus documentation and images and all of those sorts of things? How do you version control them? Which parts do you keep private and which parts do you include in your repos that you make public? It's an interesting subject, and it's not as easy as it might first sound. I've gone through. Here I am talking about this squirrel. Damn it! I've got to get back to where are we? Gluon C, which is the project I was looking for. Images, Gluon Move, and now I don't know if audio is going to work on this. Hang on. I'm just going to change over here to desktop. How do I get to desktop? There it is. Okay, so I'm going to run this little video. So this, by way of background, for those of you who haven't seen it, this is a demonstrator robot arm It's made by a company called Influx. Well, I say it's made by. It was made by. It's actually not available anymore. What happened is Infos is a company that makes actuators for robots. That's their business. They don't make robots. They make the actuators for the robots. And then those actuators are designed into other people's robots. But what they wanted to do was have a number of different demonstration platforms, kind of like a dev kit, so that if you're working on a robotic system, you can get their dev kit and use it with their examples and learn how the actuators work, and then you can design them into your own things. So this is their demonstrator robot arm, and what you can see here, these little things are their actuators. They basically look like a big cylindrical motor. They all have CAN bus and onboard drivers with position sensing. So what you do is just daisy chain them together. So this black cable that well, let's look over here. You can't quite see it. You can just see the corner here of a piece of laser cut plastic, and that's got a power supply and controller and things on it. Then this black cable that comes in loops around the back, and well, actually no, it plugs into the top of this actuator, this vertically mounted one. That is the panning actuator for the first axis. And then there is a cable coming out of that loops around, goes into the second actuator, and then there's one that goes from the second actuator, comes up here and plugs into the third, and then from the third into the fourth, and so on. So you only need to connect to the first actuator in the chain, and then you can address them all. And this particular system uses CAN bus. So what you do is you address the particular node on the bus, and you send it a command or a query. So you can say, what is your position, or what is your temperature, or what are your current limit settings. And each of the actuators has its own onboard controller with non-volatile memory. So you can send it configuration information like rate of acceleration, maximum speed, maximum torque, travel limits, so you can set limits in software, and it saves it in non-volatile memory. So this little demonstrator is a 6-axis robot arm, and I'll just hit play on this now. I'm not sure if audio is going to come through on this. It may or may not. But the thing is really spookily quiet. You can, even if it's not coming through directly from the video, you might be able to pick it up from the microphone. When the first time I got this running, so yeah, you can see it moving around there, and it's very smooth. It is so quiet that when I first got this running, what you see here is in Chris's bedroom, he's got, which is also like his home office setup, the monitors that you see behind the arm there, that is Chris's computer. And I'll just see if I can move this a little bit, get it to a position where the arm is out of the way. So there are 2 monitors stacked vertically, and then there is, just back behind it, there is his PC with some of Nick's geckos 3D printed on there. And you can see in the background there's a button box, so that's the thing that hangs off the front edge of his wheelchair and allows him to run keyboard macros, like custom input into his computer. And yeah, anyway, I'm just giving you context for this thing. So Chris's twin brother Nick passed away 2 and a bit years ago, I think it was, and so they were in the same bedroom, and it was set up symmetrically, so it's got the 2 beds and the desk at the end with 2 computers. And so the right hand computer is Chris's, the left hand computer was Nick's, but that is now where I sit when I'm there working with him. So this video was filmed basically from me sitting in my chair at my computer, just looking sideways at where he sits. And the what we did was move a table in between us so we could have somewhere to put the robot arm. And when I was first using it, I was actually sitting looking straight ahead at my computer, like hands on the keyboard, running the script that talks to the robot was sitting to my right shoulder, and I ran this script to make it move, and for a couple of seconds I was looking at the terminal while I was doing this, and the robot was moving. I didn't even realize. It was so quiet. So I was looking ahead at my computer, and I looked to my right, and the robot was moving right beside me, and I just about jumped. I was like, what? Excuse me. I need to give up smoking. So, yeah, it is a really surprisingly quiet robot. And I don't know, that was a pretty crap joke, but I've never been a smoker. So, anyway, I really like this. This is a very, very cool little device. So what we're wanting to do with this is set it up connected to Chris's wheelchair, and we'll need to put some kind of an actuator on the end of it. At the moment, there is no actuator, what you can see here. So when it comes back up to the top, this little red structure here is the output shaft of the final stage. So of the final axis. So we can rotate that into different positions. But what we could do is put some kind of a manipulator onto it, like a clasp or something. There are lots of different options there. And we could also simplify it. So one of the options is that we can just remove the last couple of stages. We could reduce this. If we took off these last two, for example, it would probably make this whole thing much easier for us to manage. So reduce it from a 6-axis robot to maybe 4-axis. Basically just start removing the end of the chain. And if you look at this area here, right where I'm highlighting, if these last two actuators were removed, what would be exposed on the end here is this red fitting right here. And we could put an actuator onto that. So we would then lose just a little bit of reach, and we'd lose the ability to move through those final two axes. But it might make it simpler from a software point of view to get it set up and control. So what we're going to do is link through to the controller. Oh, and the controller. Sorry, I should explain that a little bit. What you can't see here is the controller. And the silver thing down here is the corner of the power supply mounted on this board. So when Naomi got this, she was sent the robot plus the power supply, the controller, and those sorts of odds and ends, and it was all just sort of loose and messy. So she laser cut a base plate and then attached the power supply and the robot controller to it, and so it makes it a single module, which is what you can see there. So this is the base plate that she made for it. And yeah, when she sent it to me, it was the whole lot that she'd already put together. And then so the controller for this is really just a bridge. It's an Ethernet to CAN bus bridge, and so you connect Ethernet into it on one side, and it exposes a network socket, and on the other side it's got the CAN bus interface that goes through to the robot. And so what you can do is there's a really cool YouTube channel. Actually, this is definitely worth checking out. There's a great YouTube channel called Scientific. I am going to pull it up. I'll just find it and drop the link. Here we go. So this one here, and I will put the link in the chat. So the Scientific YouTube channel is really cool if you're interested in robotics. It's yeah. Okay. I don't even know what his name is. That's terrible. I should know. So I'll just call him Mr. Scientific. I've got this in my head, I don't know why, I've got this idea that his name is Robert, but I think I might be wrong. So, no, I don't think it's Robert. I'll call him Mr. Scientific. Yeah, so he's got this ongoing project to build his own robot arm, and so he shows all the design processes and how different actuators work and things. It's really, really interesting. So if you're interested in robots, definitely worth checking out Scientific. And what Mr. Scientific did was write a Python library for controlling the actuators that are in the Infos gluon. So I should clarify, Infos is the name of the company that makes the actuators. Gluon is the model of this robot arm. And they are now working on a new version. So there's going to be a replacement for this arm, which is going to be significantly more expensive, but also much more capable. And I think they were unrealistic with their pricing on this. So there was some controversy, I should say. The Infos gluon was put on Kickstarter. I might be getting some of my facts wrong, so I'm not going to go into it because I don't want to tell you the wrong thing. But from what I understand, what happened was that Infos, the company, had investors. Infos put up this Kickstarter campaign for the gluon arm. It was ridiculously popular. I don't know how much coverage what they got in terms of people backing it, but I think it was a seven-figure sort of thing. It was crazy popular because it's this really quiet, really smooth, very advanced robot arm that I think they had listed for like $700. Crazy price. These things are normally many, many thousands of dollars for something capable of what this arm can do. And it was really super popular, and before the Kickstarter finished, there was something happened in the company where the investors, I think, took over from the people who were running the business, and there was like some big internal thing that happened, and Infos basically went silent for a while, and it looked like the company had problems, and Kickstarter pulled the campaign. So if you actually go and look for Infos gluon now, you will find it on Kickstarter, and it will say something like campaign suspended, and it's been like that for a year or whatever. And so they have ended up shipping arms. It's in this really frustrating state where they have shipped some to some people, but you can't just buy them. Like, if you want to buy this arm now, you can't. There is nowhere that you can buy it for any price. And so I don't know all of the behind the scenes of what went on there and how, yeah, it would be interesting to know. I would really love to know. But what they've got now is, so the Infos is still in business. Their website is live, but it's not like a place where you can just go and buy things. What they're selling to are serious companies that are building serious robots and who come along, and it's really that B2B sort of thing where you might be a company that's building a robot and you needed some actuators, so you talk to Infos, and it's more of a direct one-to-one negotiation. It's not like going to an online store and adding 3 of these actuators to your cart and clicking buy now. That's not their business model. But from what I've heard from Naomi is that they are now working on a new robot arm which will be a replacement, well, not really a replacement, kind of a successor to the gluon, which will be more capable, like it'll be much stronger and able to do more than the gluon, but it's going to be more like $2,000 or $3,000, which is the sort of more in the range of the sort of pricing you would expect for a device that is this capable. Yeah, so I'd be very interested to see that. Backing up, what we want to do with this is attach it to Chris's wheelchair and then link into it to allow him to control it, and ideally we want him to be able to pick things up and move stuff around. So his total range of motion right now is limited to, I think it's approximately 10 millimeters range of motion at his fingertips on his right hand, and with very, very low force, and somewhat, but excellent dexterity. His ability, his fine motor control is amazing. So the way he uses a computer, and if we look at this video again, and you can see in the background behind here, so there's the button box which goes on his left hand, which detects switch activation and then sends keyboard macros. And what he does is his right hand rests on a mouse, and you can see the mouse is just sitting here on the there's like a little foam support. There's the mouse pad, and so what happens is that this is all lifted up onto the tray on the front of his wheelchair. So the wheelchair moves into this space, and then his right hand rests so that his fingers are over the mouse, and he only moves the mouse a couple of millimeters. You can barely see that it's moving, but it's a gaming mouse with 24,000 DPI resolution, and he uses it with everything turned up to maximum, so like maximum acceleration on it. Basically you touch it, like you tap the mouse and the cursor goes from one side of the screen to the other. But his fine motor control is so good that with those tiny movements he can use on-screen keyboards and drive Fusion 360 and do all of those sorts of things. So what we're going to try to do is link a control system into this arm so that he can then use like a custom input device to send commands to the arm to move it, and it can reach out on his behalf and do things. So that's what we're aiming for. And on Tuesday, so this video that I just played here, this was recorded on Tuesday, and this was running off a little Python script. And there's an example Python script that Mr. Scientific has provided with his library. So I looked at that and figured out how he was sending the commands. Basically, he's got one script that initializes the connection, it does the handshake to the robot, and then another one that sends commands to move to different positions. So I munged the two together and made a single script that initiates the connection and then goes through a series of locations. And so we're thinking about how we can link into that. So there are two options. We can either, in terms of the control side of it, not the output side of it, we can either keep working with the current Ethernet to CAN bus bridge, which means that we would just make socket connections, like network socket connections to the controller, which is what we're currently doing, or we could just talk directly on the CAN bus. So that's what we may end up doing, because the thing is that our custom wheelchair interface already has CAN bus on it, so it's just some software changes. Basically, we just need to make up an adapter cable. Essentially, we've got we use the little 8mm circular. What are they called? I've gone blank on them. All right, I'm going to look this up. Where is my wheelchair interface directory? I've got to find that. Images. Come on, open up. Alright, so this is part of my wheelchair interface project, which many of you will have seen already. And the early versions were just simple breakouts. So it started off, and here's an example. These were our first couple of versions. It's basically got an Arduino on a carrier board, and it acts as a breakout for the existing wheelchair controls. And you could take 2 joystick inputs. There was one pass-through output, and then we could send to other things. We didn't have CAN bus on it then. The current version is much more sophisticated than that. Let's find an example. Oh, this is... don't know what... Okay, so this is 2 of the chair breakout minis connected together. Are they connected? No, they're not. They're just plugged in and running. Why am I even... What was I doing in that photo? I don't know. Anyway, this has CAN bus on it. And so what we can do is... so one of the reasons for that is if you look back at the original version... So this one, see how we've got 2 inputs into here? This is so we could have 2 joysticks. And the idea with this was to be able to replicate the control that you require for flying a drone and be able to do that from wheelchair controls. So what you would do is have, say, the regular joystick, the regular wheelchair joystick on the right hand side, and then mount a second wheelchair joystick on the left side, which gives you the control for the axes, the 4 axes you need for a drone. And so that's why it's got 2 inputs. And then it would take that information and combine it and then send the connection off to like a FlySky controller for flying a drone. But what we managed to do is we didn't need the 2 inputs, the 2 different axes inputs with the new version. Oh, this is what got me started on this. So these are the connectors, the little 8mm circular connectors that we use for CAN bus. So these 2 connectors here are CAN connectors, and that's the pass-through connector that goes to the chair when you put this in series with its normal control system. Here's a better example. Alright, so what we've got here are 2 of the chair breakout minis linked via CAN bus. So what we can do is have a joystick plugged into each of these, and then you treat one as pitch and yaw, and the other one as roll and throttle, or whatever combination you want. But because they are on CAN bus, we can just daisy chain them, and we can have as many axes as we want. So we only need to connect one. Let's see if this is a better example. Mini joystick. What's going on with that? Yeah, this is showing passing the CAN bus through, but anyway. I'm off talking about random things here. Where is an example? Just trying to find... oh, well, this is a... Is that a photo? Yeah, that's just a photo, not the video. There's a video somewhere here of Nick playing a car racing game using this. Don't know where it is now. Anyway, the point of all of this is on our existing controller, which is this one. No, that's version 2.0. There's now a version 2.1, but it's basically the same thing. So with this, what we can do is take the input from the wheelchair controls and then send that out via CAN bus. So with a link between the Infos gluon, M8, yes, Ben said M8, exactly. Metric 8mm. They are M8 connectors. Mate. So what we can do is make a cable that goes from one of these CAN bus connectors and goes to this basically, like plugs into the CAN bus interface on the first actuator of the Infos gluon, and then it's just a matter of some code. So we send the correctly formatted CAN bus messages, the frames, to make it do what we want. And that way we could eliminate the existing interface entirely and just talk straight to the controllers, the actuators rather. So, okay, so looks like there are some interesting questions here. So all of this came from Austin's Creation saying, how's the robot arm coming along? Okay. Ferenc said, hey guys, you just saw the new ESP32s, the S3, the C3. The short answer is yes. And if you are a very special person, then like Sion, then you might have actually had one physically in your hands and been able to do stuff with it. Yeah, they look like really, really nice microcontrollers. And I think it's the newest, I think was it the S3, is probably going to become my new favorite MCU once it's available. It looks like a really good balance of things, and anyway, okay, I will avoid that score right now. But yes, Ferenc, they look really, really good. I haven't seen this one. So Ben said, I imagine lots of people have already seen it, but the channel Dave's Garage has lots of war stories from working at Microsoft during the NT XP sort of time span. That is interesting. Chris Hiscox is here. Managed to get in before the end. So, yes. Oh yeah, so Ben said ESP32 has an interface too. Apparently you would have to add an external transceiver though. Yes, that's what we did. So all of our assistive tech projects have got CAN bus on them. So if we look at the, where is it, the hand heater? Is it in this directory even? Yeah, our wheelchair hand heater uses an ESP32 with CAN bus, and we've used an external transceiver, but the built-in controller. You don't need an external controller with the ESP32. And where is that? I think that might be in my projects that have not been sorted. Projects unsorted. I'm revealing all sorts of things today. So where is this? Hand heater, there it is. Alright, hand heater. Why are there no... Oh. It's because the capitalization is screwed up. Let's see what we've got in here. Have we got any pictures of the controller? Well, there's the original one, I think. This is the early one which had an AT Tiny on it. V1.0. This was the controller board out of that hand heater. Where's the current one? Okay, this one. So this is the current version of the hand heater. It's got a Vroom 32 on it. And that little chip just there that you can see, that is the CAN transceiver. This jumper is for the CAN termination. You put a jumper on there, and just back there you can see the little 120 ohm resistor. So that's the CAN header on here. And so we're using the internal CAN controller. And if you look at the back of the, so this is the back of the enclosure for it. You can see the CAN bus headers on here. So we can link the hand heater into our little wheelchair CAN bus as well and control it and have it report stuff. So, yeah, you can see a few of them there. So you can see the internals with the, there's the little subboard on the back that's got the breakout for the CAN connectors because they are designed to have flying leads soldered onto them, which are terrible. So what I've got is this little PCB inside the back that has pin headers in it, and the pin headers solder onto the back of the sockets, and then from there we use a header and then a flying cable that goes down to the CAN bus header on the main control board. And you can see the vertical PCB here, which holds the blower and the heating element. Yes. So, where... Oh, Peter, cool. So you've found Mr. Scientific's name. Gennady Pliashchev. Pliashchev. Yes. So, oh, Frank said MQTT to CAN, a whole different mindset. Yeah, I've done that too. Any idea of the weight? Okay, so getting back to this robot, where are we? Oh, Dodgy said, I cough a bit like that lately, think it's early asthma. I hope you don't have early asthma, Dodgy. Stay healthy. Peter Lawler said, easiest way to give up smoking is to stop setting yourself on fire. Never! I will always set myself on fire. So Chris asked, any idea of the weight of the arms? And there was a related comment about specs, I think. Yeah, so the weight, in terms of what this overall arm weighs, it's actually really quite heavy, surprisingly heavy. A fair bit of the weight is in the base. What they've done is tried to minimize weight of the arms. So the, what did I do? I maximized the screen. Can I unmaximize? Yes. So what they've tried to do is minimize weight. They've used carbon fiber tubes in here. The bodies of the actuators are carbon fiber as well, which often is done more for cosmetic reasons than for practical reasons. But hey, in fact, I'm not even sure if these bodies really are carbon fiber. The tubes, I'm pretty sure, really are. They're that sort of matte finish. They're not, like carbon fiber sticker. And these brackets are really nicely made. They're a work of art. When you actually see these up close, they are amazing. Someone put some real effort into the design of this. And the arm has, it can lift, the specs are, it can lift 500 grams at 500 millimeters distance, I think. I'm sure of the 500 grams, that's what it says, but I'm not sure of the 500 millimeters distance. So 500 grams is enough to actually be useful. If you look at a lot of little robot arms, like hobby robot arms or, toy robot arms, they often have trouble just lifting their own mass. And at full extension in particular, when you've got the most mechanical loading on it. So doing anything useful with them is really hard. Something like, a can of drink, that's 370 grams or, whatever the weight is. So round it up, say close to 400 grams. So if you want to be able to pick up a can, you need to be able to lift 400 grams at the full extension of the arm. So this one can do 500 grams at full extension, which puts it in the region of doing useful things, like being able to pick up a load like a book or, small objects that you might have around the place. It's not in the multi-kilo region, but it is certainly enough that it's a worthwhile project. And if we could, Johnny's trying to get me back on track. Yes, let's do that. Okay, so it's it's enough to be useful. Yeah. All right. Now, Ferenc said, CAN is good for wide home automation too. The line drivers are cheap. Yeah, I don't want to do... I do want to talk about ESPFlash. Yes, Peter is wondering where that squirrel went. Ferenc said maybe ROS can be used for complicated things. Yeah, this robot arm, I could talk about this for the rest of the live stream. So ROS, Robot Operating System. The big issue with this, I'm going to get onto ESPFlash in just a second, I promise. The big issue with this is a topic or a problem called inverse kinematics. And inverse kinematics is a way of back calculating when sorry, no phone calls, broke my concentration. If you want to control a robot, the human or logical way of thinking about it is, I've got a series of joints and I want to control the joint and move it to a certain angle, and then you will get some result at the end. And that's forward kinematics. It is when you are taking a movement, like an angle or a movement, and you are causing some effect. The thing is that most of the time that's not what you care about in reality. What you care about is the end result. So if we're looking at this arm, for example, and we want to move, if we had a gripper on here, a gripper, getting back into the Roman emperors. No, I will not get into Roman history. Tempting as a squirrel, that is. So if we had a gripper on the end of this robot arm and we wanted to reach out and grab a can, what you care about is the position of the gripper relative to your target. You don't care about the position of all of the joints or the articulations that are required to move the gripper to that location. So you can think about it as kind of one level of abstraction. From your control point of view, you want to control the location of the gripper. You don't want to have to care about all of the segments that go back behind it. That's where inverse kinematics comes in. What it does is perform those reverse calculations to figure out, okay, you have instructed me to move the gripper to this location. Now, what angle do all the joints have to be in order to achieve that result? And then send the commands to the joints individually to make that happen. And that is a complicated problem. It requires an understanding of the geometry of the robot that you're moving, the possible ranges of motion, all sorts of things. And that's where ROS can come into this. So part of this whole project is going to be figuring out how we bring inverse kinematics into this so that Chris can control the end. Basically, all he has to think about is the position of the gripper. So move the gripper in space and grasp something, and the rest of the robot arm just does what it needs to do to make that happen. Big subject. All right, let's try to get into ESPFlash. Okay, so Andy said, ROS2 for robot arm geometry model, inverse kinematics and SLAM when things become mobile. ML for machine vision and ML for vision perception and potentially grad SLAM. Yes, so that's a good summary of all of the things. All right, so Johnny also said, are we going to talk about ESPFlash today? Maybe. All right. Yes. Okay. Long flare. Chip, my old friend. Thanks for coming along. Roaming is much of the point of this exercise. Yes. We are chasing squirrels all day, every day. Now, all right. So, I wasn't even really sure if ESPFlash would be an interesting topic for all of this stuff. Let's talk about it. I'm sure I can chase that squirrel for a while. So firstly, let me off camera find a couple of things. Now, where am I going to find relevant images? Ah yes, I know. I've got a project called ESPFlash, which I think has the... Alright, this'll do. Okay, close enough. So, I've generated so many visuals for this and then not even used them. Okay, for those who weren't aware, this is related to the video that I uploaded a couple of days ago, which is about programming headers for expressive chips and my quest to standardize on something. The backstory is that I wanted to be able to, in fact, the backstory, it largely comes down to this. I think it was the hand heater was where I first hit this problem. Let's have a look. This one. Yes, there it is right there. The whole genesis of this issue was in the hand heater. So with the hand heater, we wanted an ESP32, so this has got a Vroom32 chip on it. And yes, I know this has got terrible design in terms of its radiation patterns, and it's going to have terrible Wi-Fi performance. We didn't actually even put this chip on here for the purposes of Wi-Fi. That's kind of a side effect. So the hand heater can be linked into Chris's OpenHab thing for home automation control. So he can control the heater on his wheelchair from his home automation system. So that's another squirrel I'm chasing. Okay, this header right here, this little 4-pin thing, this header that I put on it was actually the same format as on a Sonoff Basic. And I did this because I needed to be able to reflash the controller for the hand heater, but I didn't want to put a full USB interface on here. There was no point, and frankly no room, unless I did radical changes. No room for the connector, quite apart from anything else. And this thing is jammed across the back. Maybe I could have removed this voltage regulator, but there are mechanical restrictions around here. You can see the mounting points here, and it's just there's not a whole lot of space there. So I needed to be able to plug in for loading new firmware onto it, but I didn't want to put a full USB interface on it. And Ben said we weren't off track after all then. No, I even had the directory with the images open right there. And I kind of defaulted to putting the same header on as a Sonoff Basic because I didn't know what else to use. And I looked around, and so some of you will have already seen this little thing. This is the, it's actually two things combined. This part of it is a USB to serial converter, and it's all covered in heat shrink so you can't see it. This part of it is an adapter, so there's a 6-pin header in the middle here, converts it to a 4-pin header. This header is designed to plug into a Sonoff Basic, so you can reflash it. Just plug it in, put it into bootloader mode, and then you can use Tasmatizer or whatever. It was no room. I ended up putting the 4-pin header on it so I could do this. And then you can see down the bottom, got to switch back to the desktop. You can see down the bottom there is a reset pin and a flash pin button rather. So you would hold down flash and then press reset while continuing to hold flash. And then you let go of flash, and then it's in bootloader mode, and then you can use this and load new firmware onto it. So that kind of annoyed me, and what I wanted to do, oh look, here we've got, I'll just find, switch back to front camera. There we've got one of the little, what did I even call these things? Son-off programming adapter, so an SPROG. So it's got the FTDI connection across the back, it's got the 4-pin header for the son-off on the front, and there is a button. This is actually a really funky little button. It looks like a regular tactile button, but that is actually a normally closed button. When you press it, it goes open circuit. Had to order those specially. Yeah, quite cool. So the it's a normally closed button in series with the power line. So what you can do is, when you've got this plugged into your son-off, all you have to do is press this and let go of it to power cycle the son-off. It kills the 3.3 volt input and then brings it back again when you let go. So normally closed tactile button. It's the only time I've ever used those on a project, and I don't know if I ever will again. So this was the genesis for all of this. So what I wanted to do was incorporate control of GPIO 0 and reset into the header, and that got me going off down the track of trying to figure out what pin header to use. And as I showed in that video, there are many options. Let's see if I can find, I don't even know if this is the right directory that I'm looking in. Oh yes, it is. This one. Here's another image. Okay, so this was the little summary that I did when I was looking at what was around at the time. So this was a while ago. I think I made this table about 1.5 years ago. I did it originally in Google Docs. It wasn't quite this pretty or ugly, depending on your point of view. This is the version that I did just recently for the video. So I started off with the son-off 1x4, and then I was just looking at other options, like what could we use to add the reset pin and IO0 so we can force bootloader mode. And one that I did not put on here is I really should have included the FTDI header in here as an option, because in some circumstances you can use an FTDI header. This is something I didn't really, there are a couple of things I kind of glossed over in that video. I didn't explain myself very well. Two things I didn't explain very well in particular. One was the FTDI thing, because some people do put FTDI headers on their projects and use them quite effectively, because you can use the DTR pin to do the control of IO0, but only in some circumstances. It depends on the particular adapter and how it's been set up. So there are different options for the way the DTR pin can behave, and most simple USB to serial converters do not implement it in a way that's useful, or don't implement it at all. UEP has just posted the XKCD 927. So so one other option would be the 6-pin FTDI header and use DTR to control IO0. But I kind of discounted that because of the two reasons. One was the vagueness around the behavior of DTR, and most adapters that I've seen just not implementing it, or not implementing it correctly. And so yes, I actually did think about for a moment I contemplated naming this standard something like ESPFlash 927 as a homage to XKCD 927. So where am I going with this? Okay, two reasons, as I said. One is the lack of DTR behavior for putting into bootloader mode on IO0. The other was the order of the pins, and this really does, this is the killer. The son-off 1x4 I want IT to implement this. Like, I want them to extend their header and add reset and IO0. So in my mind at least, when I was looking at the options, these 4 pins right here were fixed. I decided quite early on that whatever else I did, those 4 were going to be the same. Now, one thing that I did not explain properly in the video, and I should have done a better job of this, is the whole thing about the WESP32 header. Now, I really like what Patrick has done with this, but I didn't use it. One of the reasons I said that I didn't use it is that I wanted the pins to be in the same order as the SON-OFF header. Now you can see here, SON-OFF goes ground, TX, RX 3.3 volts. Now look at the WESP32 header. Ground, TX, RX, and power. Now apart from the 5 volt issue, let's just ignore that for now. Imagine this was 3.3 volts. Those pins are in the same order as this. It is actually the same. So what I could have done was add IO0. Hang on, I'm going to close this and go to another image because I want one with the other headers included. Okay, the ESPFlash 1x6. So you can see here that I've got the first 4 being the same as the SON-OFF, which is also the same as the WESP32 headers here, but the extra pins are added at the other end. On Patrick's, he's got IO0 and reset or enable. There is a subtle difference. I won't go into that now. I'm just calling it reset. So he's got them at the other end, coming off near the ground pin. I've got those same 2 pins coming off near the 3.3 volt pin. I could have used the same order as Patrick, made everything the same except 3.3 volts and instead of 5 volts. And in some ways that would have made sense. Now, one thing was, by making it distinctly different, it means that there is less confusion of someone mistakenly looking at that and then looking at this other one and plugging it in when it's got 5 volts exposed and we're only expecting 3.3 volts. So it's obviously different, and so it avoids that sort of, oh, they could be interchangeable confusion, and someone plugs it in and damages their board or destroys their board. But that's not the real reason. The main reason is if you look at a SON-OFF basic, SON-OFF pinouts, where is it? I'm just going to find a, is this the basic? No, that's the ZBR. Somewhere I've got a picture of a SON-OFF basic. But anyway, the point I'm trying to make is that if IT are going to extend the header, they, unless they move things around, they can't do it by adding the new pins adjacent to the ground pin. It has to be extended adjacent to the 3.3 volt pin. And that is just because of the physical layout. So I'm just poking around here and trying to find a photo. It's 55. I wonder what the deal is with this. Like with this example. Okay, so the S55, this is the board inside a SON-OFF S55. You can see that they've got ground, TX, RX, VCC. So I'll move this across here so that you can see that and the other thing at the same time. And in this case, VCC is 3.3 volts. So it's adding the extra pins on the end from VCC up here, not from ground down here. Now the reason is, on the SON-OFF Basic, which is still their most popular model, ships in huge numbers, crazy numbers, there is a button right here. And unless they move the header, which would then upset their pogo pin programming jigs, they can't move. They can't add 2 more pins down the bottom here. There just isn't the space for it because you know, right this area where I've highlighted right here, approximately, there is a button in that location. There's the tactile switch that comes through the enclosure and allows you to control it locally. So the only way to extend the header in a Sonoff Basic is to put the extra 2 pins right there and extend it. So it goes ground TX, RX, VCC, and if you look at our table over here, ground TX, RX, VCC, and then add reset and IO0 on the end. Can't be done by extending it down this way, which is what would be necessary to, oops, wrong image, which is what would be necessary for the WESP32 format, unfortunately. So when it all comes down to it, if Patrick had put these pins on the other end, even with the voltage difference, I think I would have just adopted his header format. So anyway, I didn't. So the end result is that I ended up adopting this format. So also one thing I wanted to say is how good it is to use an IDC cable for the programming header. So I really like this programming header, surprisingly. Here's an ESP-prog. This is, so do we have overhead camera? Overhead, there. You can see a little 2-year conversion that I've got going on there, a Tasmota thing. So this is the ESP-prog, which is Espressif's official programmer. And you can see the JTAG headers here. So standard 0.1 inch pitch and 0.05 inch pitch. This pair of headers has the exact same pinout. And likewise up here you can see these 2 headers have the exact same pinout. It's 2x3, it's just in the 2 different sizes. And what I've found is super useful is using these little 0.05 inch pitch IDC cables. Oh, here's an example of one plugged in, because you can just have the adapter sitting on the bench. So if I put the 1x6 header onto a target board, this is what I need to have plugged into my target. So I don't know, just grabbing this, imagine this was my target. This is a large, well, it's not that large, but it's a relatively large, heavy thing on a USB cable, which is not that flexible. So what happens is you end up plugging it in, and then it becomes a bit of an unwieldy thing on the bench. It gets in the way. But this little thing here, if you've got a 2x3 0.05 inch box header on the target board, and you do this, so plug that into the little adapter, and then you plug this into your target board, that is really nice, because this can just sit on your bench somewhere, and this is small, it's very flexible, and it's much more convenient. Like when you're picking this up to move it and you're sticking it under the microscope, or whatever it is that you're doing, getting probes in there to like for a multimeter or scope or whatever, having this as a programming header I have found is super convenient. I ended up putting one on a board. In fact, the Air Quality Sensor Pro, where is that? It's probably around here somewhere. Here it is. Air Quality Sensor. Let's see if I can get this back up without dropping it. Let's see if I can find, where is one in here that has got the header on it. Yes, here's one. Here's a butchered one. Oh, 2 different versions. There's one, there's another one, These are both hacky prototypes, as you can tell by things hanging off them. A couple of different versions I've tried. There's no screen plugged in on this, but you know, that screen just plugs in. So it's got the PMS7003 particulate matter sensor, so the laser scattering sensor. There is a 240 by 240 color LCD on the front, and you can see this version has two WS2812B LEDs, and this one has 4, so 2 on each side. This was an earlier design, I think. This one had a CP2102N USB to serial converter on it, and then for some stupid brain fart reason my mind went, I don't know, some neurons misfired and I put a CH340G on there. I think it was basically because I was just annoyed at soldering these things on, so I thought, oh, CH340G, it's got a nice big package, much easier to solder on, so I switched to that, and that was a mistake. Anyway, the point of all of this is, see on the right hand side here, there is the little programming header. Now neither of these ones have got the programming header populated because it does have USB on it, and I can just flash off USB. It's got the auto reset circuit, does everything. So with this, in fact, let's just plug this in and see what happens. I don't even know what software is on these, if they're running, if they do anything. The power LED has come on, but apart from that, nothing. I've got no idea what this is doing or what state I left it in. Let's try the other one. Plug the display into there, power it up. Oh, we've got red. That's a start, and then it goes green, and then I think it goes blue once it connects to MQTT, which it's probably not going to do. So what I've done in this case is use the RGB LEDs in a way. So this is something that Andy, who is here in the chat, has done for years on his projects, is he uses colored LEDs, so RGB LEDs, to show the status of things like the network connection. So when it first starts up, it can be red, and then when it connects to Wi-Fi successfully, it goes, oh, hang on, no, green means it's good. Okay, so it goes blue to show that it has connected to Wi-Fi, and then when it connects to MQTT, it goes green. So what you can see, just by watching it, you can see the boot up process, and you know that your device has finished. Like, you know how far along it's got. So if, for example, it has managed to connect to Wi-Fi, but it's failed to connect to your broker for whatever reason, it'll just stay stuck on blue, and then you know that's the problem you've got to diagnose. So that's the method I've been using as well, copied blatantly from Andy. So this is the point of showing you this was the programming header, and it's not even soldered on that one. Do I have one here with the header soldered on? No. Anyway, I put it onto this project. Oh, and just for the fun of it, here's some 3D printed enclosures that this goes in. Oh, here are some more enclosures. So the point of this project, no, not the point of this project, the point of what I'm talking about here. Screw that on. Yep, so you can see the mode button comes through the back. Screen is visible on the front. Sensor is exposed underneath. Oh, and it's also got a BME 680 on here, so it can do particulate matter, but also temperature, humidity, barometric pressure, or volatile organic compounds. Or you can see the color glowing through the enclosure there. You can see it a little bit better in real life than you can on the camera. It doesn't really pick it up very well. So the idea is that is the pro version of the air quality sensor. So they could sit on a mantelpiece or something and display air quality information on the screen, and yeah, sensor exposed on the bottom. And the idea is that if you want to toggle through different screens of display, you can, you know, the mode switch is on the back, but it's positioned so that you basically just you grab the right hand side and squeeze. So while I was working on this, what I found was that this little header, the little box header, It was super convenient, and I really liked using it. So I've ended up using this 0.05 inch pitch 2x3 header as the programming header on many different ESP projects over the last year and a half or so. In fact, if you look behind me, the water cannon, it's not the yellow one that's been here previously, it's the grey one, is the controller for that uses, well, actually no, a previous version of the controller for that had an ESP32 on it, and I ended up switching to a different MCU, but so I don't have that header on it anymore, but the previous version of the controller for that had the little 0.05 inch pitch header, and in fact the joystick, which is a CAN bus controller that talks to it, does have an ESP32 in it, and that does have that same programming header in it. Anyway, my point being, I like this header, and I'm surprised to say that, but I think that that ESPFlash were actually on the right track when they made their ESP prog reference design, and it worked out really well. So, comments. What am I missing? Oh, there's been a lot of discussion. Don't know if I can get into this. A whole lot of stuff about RISC-V. Yes. There is there are squirrels there. Let's okay. IDF is the firmware. There's been some very active conversation about ARM and RISC-V and Tensilica, different cores on different microcontrollers. All right, there are people in the chat who know more than me about that sort of stuff, so I'm going to defer to them. Greg said, coincidentally, I've made an ESPFlasher with the same pinout as this ESPFlash, so that's good news. Awesome! Out of pure luck, mind you, Greg says. Greg, is that something that you have released? Like, is it available for people to buy? I would love to know about that. So if you've got a link, maybe drop the link into the chat. Like if you've done a blog post about it or anything like that, because the point of me doing this is not for me to sell 1 billion ESPFlashes and retire to the Bahamas. It's to have something that people can okay, so this gets back to my original thing about when I was working on that hand heater and I started looking at all of the different pinouts that people were using, and the more I looked, the more obvious it became that there was just no consensus around any of this. People were coming up with their own header formats because there was no obvious choice, and that's what I was trying to solve, was just saying, okay, I've looked at all of the options and this is what I've decided on, and I'm going to document it so other people can choose to use it or not use it, but at least there is something that you can point to and say that is a documented thing, and we can have some consensus on it. So if you are producing your programmers and they have this header, that is fantastic. I hope you do sell 1 billion of them and retire to the Bahamas. And so if there is information about it, so Ben said, got to sell at least 2 billion for a fancy retirement. Yeah. Please drop a link in the chat. It may not if you do put a link in the chat, it may say that it's been held or blocked or whatever, because you're not a moderator, but then it can be approved. So if you have a blog post or a GitHub repo for a project that uses this header or whatever, please share. I'd love to see it. All right, so okay, so there's a little squirrel here. This won't take long, I promise. Matt asked, why was the CH340G a mistake? And Stephen said, because the CP2102 is better. Didn't say why that was a mistake. I'm not quite sure I understand Dodgy's comment here. Sorry, you meant the current project. Didn't say why that was a mistake. Okay, the CH340G has a painful history in terms of compatibility with macOS in particular. And so it's cheap, and there are clones of it. So the CH340G is used on a lot of the D1 Mini clones in particular, like the Wemos D1 Mini, and it's really hit and miss. You can get it's one of those situations where you can get a CH340G in one batch and it will work fine. You get a different batch and all of a sudden you are kernel panicking people's Macs, and that is really, really bad. And I know the OS should not, under any circumstances, allow itself to be kernel panicked by just plugging in a USB device, and that is a failing of macOS. But still, if you produce a device and someone plugs it into their computer and it spontaneously reboots, that is really, really bad. So I've gone away from the CH340G. The CP2102N has some disadvantages. For example, you need to set it up. Just out of the box, it doesn't. There are a couple of things that it doesn't enable. So things like the activity LEDs. It has a number of GPIOs on it, which you can configure using Simplicity Studio. But I think out of the box, the activity LEDs are not enabled. So what you have to do is, for each device that you make, that you put a CP2102 on it, you have to run Simplicity Studio to load a configuration onto the target, and that turns on the GPIOs and sets it into the right mode. And also you can do things like set how much the current rating that it will request from the host. So in my case, I just always turn it to maximum 500 milliamps. Ask for everything. Give me the world. Yeah. So Ben suggested if you can spare a bit more space for alignment holes, Tag Connect uses the same 0.05 inch 2x3 footprint. Yeah, so Tag Connect is something that I've seen many, many times over the years, and I've never personally used it. It's... do I chase this squirrel? It's kind of on topic. But before I do, there was a quick question. Where? Sorry, I know the question. I'm just looking it up because I want to refer to the right person. Oh, right, it was Ferenc said, the wheelchair is using CAN bus exclusively, or LIN bus is also included. No, it's using CAN bus exclusively. And that's really two different things that we're talking about. There's the original wheelchair control system uses CAN bus, and our new devices that we've made also use CAN bus, but we don't link those two buses together. We have our own CAN bus that we use for all the peripherals that we've added to the chair. All right. Yeah, also Matt said, excuse me, 2 hours of continuous talking is just a little bit too much for me. All right, so Matt said that the CH340G has always been reliable for him, and that he's been on Windows. So yeah, On Windows, I believe that it pretty much always works. It's not a problem. But for... Ooh, cool. Sorry, I'm also doing a search. Aha, nice. This. I'll just bring this up and refer to it again in just a moment. So, yeah, CS340G. On some platforms, it's just a horrible, horrible nightmare of incompatible driver versions and things. And you can have two CH340G chips that are supposedly the same, and one of them will kernel panic a Mac with one driver, and the other one will kernel panic a Mac with a different driver. And yeah, it's just frustrating. So that sort of uncertainty and frustration just made me think, no, throwing out all the CH340Gs, and the CP2102N is totally reliable all the time. Dodgy said, if it only affects Macs, I see no problem. Yes. And and Matt said, and for more, I'll get my code, I shall leave this here. FTDI for the win. Yeah, FTDI kind of burned me when they did that whole driver brick your device thing a few years ago. Yes, I know it's a, yeah. All right. Yeah, so Tag Connect. Tag Connect is one of those, Peter Kirkos said, drink some grease, or WD-40. Yes. Well, this is Pepsi Max, so it's like grease remover. Maybe that's my problem. Tag Connect is... Okay, before I get onto that eFlashy32 thing, which is cool. Tag Connect. I'm going to pull this up for the benefit of people who haven't seen this before. No, not Tag Heller. Tag Connect. Is it one word? Tag Connect. This thing. Alright, it's a programming header. The idea is to put all of the expense into the programmer and remove it from the target board, which is very important, obviously, in terms of cost saving. Something's creaking in the room. I think it might be my chair. So instead of having to put a header of, like a pin header or a socket or anything like that onto your target board, what you do is simply put a footprint on the PCB design, and it's just got pads and alignment holes, and that's it. This is cycling through. You can see there, it's got the contact pads and then 3 alignment holes, and then you use this header, this connector, which has pogo pins and alignment pins, and you can get them so that they either clip into place and will be retained, or they're just push on only, depending on what. So you can see this one clips in, and then you'd have to squeeze it to remove it. And so what that means is that all you need is a bit of space on your PCB, and then your programmer can clip into it. So that in itself is very cool, and if you want to use Tag Connect, that's fine. The only thing is that these connectors are they are expensive, which is not necessarily a big problem. I think from memory they're in the order of $20 or something for a cable with the connector on the end of it. And if you're only buying 1 or 2 of them, then that's fine. But one of the things that I have a problem with is that I understand from a business point of view why they've done it. What they've done is been very aggressive about preventing anyone else from producing compatible connectors. So if you implement Tag Connect on your board, you can only ever buy connectors from that one place. And yeah, that makes me uneasy. So yeah, you can see here, no, don't use this big nasty box header with an IDC cable. Instead, use a Tag Connect, and then you don't need to put anything else on your PCB. So yeah, I first saw Tag Connect quite a few years ago now. When I first saw this, my initial reaction was, that's awesome! I've got to implement that on my boards. And I just haven't for those reasons. It is actually physically, if you do the version of the footprint that has the clips to be retained, it's physically quite large. It takes up a fair bit of space on your target board. So this comparison here, where they're doing the box header versus the Tag Connect header, that's not really a direct comparison, because if you do the version that has the retention holes in it, the holes are large and they're out on either side of the connector, and it takes up a lot more space and it becomes much, much bigger. So that's a 10-way IDC header versus a 6-way Tag Connect header as well. So they've stacked the comparison there. I wonder if I can make this little thing stop scrolling. Can I do? No, I just want to stop it on this image. So yeah, you can see this is a 10-way IDC header taking up this large bit of space versus a 6-way Tag Connect header taking up a small amount of space. But the 6-way header here doesn't have the retention pins in it, and so a 0.05 inch pitch 6-way box header, like IDC header, is actually similar size to this. It's a lot smaller than what you see here. So the Tag Connect doesn't have the big size advantage that it looks like it has when you compare it just here, the way they've done it. Yeah. Oh, Greg said, Tag Connect is an awesome idea, but for open source hardware, I don't think you should assume people will have that kind of bling. Exactly, yeah. So if you design something onto your board that requires a $20 connector to go onto your programmer, that's not ideal. Oh, Ben Harper said $40 to $50 US. Ooh. Oh, Matt said, looks like you could make your own Tag Connect with 3D print and pogo pins. Yeah, many people have done that. It's that's the workaround, but it ends up being kind of cruddy, to be honest, because the 3D printing, to make this really work, you need the alignment of the pins to be pretty good. It needs to be strong. It is fairly small. So the way I've seen it done is you use a PCB with pogo pins soldered flat against the PCB, sticking off the edge from both sides. So the PCB, if you look at this picture here, imagine a piece of PCB that is vertically coming up from this board at right angles, and it's aligned with the pins, and then pogo pins, so 3 pins on each side of the PCB soldered flat against it, sticking down, and then that PCB can go to an IDC cable or whatever you like. So yeah, you can do this, but making it nice mechanically, to do it properly, you really need, like, if you look at their connectors, they are beautifully made, and I've got to say, they have done a good job with designing this thing. Let's see this. See if I can find a better picture of the connector. Oh, and look at the prices on these. Yeah. So the footprint. Oh yeah, this gives you a better idea of the footprint. They've listed it on their online store as $0, and that is really the killer for this. You don't need to do anything on the target board. All it is a bit of some pads and some holes drilled in it, which is just part of your PCB design. But you can see here the big holes that go on the side if you want to use the retention clips, and then you've got to route your signals around through here. It's actually kind of tight. And then if we look at 6-pin cable, I know this one will do. It doesn't matter which one we're looking at. Can we look at a zoomed in version? So this is the Tag Connect connector with the pogo pins in the middle. It's got the guide pins and it's got the retention clips. Being able to 3D print this is actually quite tricky. Making it strong enough that those clips will work and retain it, not snap off every 5 minutes. So yeah, I've seen a few people 3D print their own equivalent to this, and it just doesn't work out that well. It's just kind of disappointing. but putting the 2x3 ESPFlash header, where is it? That one. Putting this one on a tag connect header, yeah, go for it. If you want to do that, you certainly could. Just use their cable. So, okay, I'm kind of running out of time, but let's just have a quick look at, yeah, okay. I agree to your cookies, Mr. Tindy. So let's have a quick look at EFlashy32. So this comes back to, where was it? Back in the chat. Someone else said that they had implemented the a header, which here we go. Oh, Johnny Bergdahl has put the link in as well. So github.com gcormier EFlashy32, and this is Greg's Tindy store, and this is the flasher, which is cool. So it looks like you've implemented two different sizes. Is that correct? So it's got, you can either do, let me read this. So, what have we got? You've implemented the same pinout and the same pictures. That is awesome. I'm so pleased to see this. I'm going to add a link to this from the ESPFlash page. So this is basically another implementation. Let's see. Not that. I want to go ESPFlash. So this one that I was just showing you on the overhead camera earlier. This is my implementation of it. And sorry about the horrible out of focus photo. Couldn't get enough depth of field there. I need to work on that. So this header that you see there, the 1x6 header, this is USB-C going through to the USB-C going through to the 1x6 header in 0.1 inch pitch format. And what Greg has implemented here looks like the exact same header. This is so cool. I'm so glad he did this. Now, does that have switchable output voltage? Is that what that switch is for? Can we see it a bit more clearly? Oh, power. Okay, so you can just isolate power from the target. That's cool. So it's got activity LEDs, and then you can put the pin header on the end. If you put it on one side, you've got the 0.1 inch pitch, and on the other side, it's got the 0.05 inch pitch. That's really clever. I like that. Maybe I should change mine to do that sort of thing. At the moment, I've got these right angle headers going through. But what I could do is put exposed pads and have 0.1 inch pitch on one side and 0.05 on the other. Yeah. Nice. So, Greg, good work. Alright, I'm going to add a link to that from the ESPFlash page. And if any of you implement other programmers or you come across them, it would be nice to have some more implementations of that same header. Please let me know, and I will add a link to that page. I will do that right after. Yeah, I'll do it this afternoon. So Scott suggested put the sockets in a DuPont connector shell and bend the pins over. Yes. That would do the job, I think. Yeah, there are some interesting ways that you could achieve that structurally. Peter said, midday, that means it must be time to go to lunch, hey? Yes. Yeah. Alrighty. Can't chase squirrels on an empty stomach. No. Oh, Ben said, Jeff Geerling did a video on stacking multiple images to fake better depth of field. Yes, image stacking. My camera does that. So this is referring to, where are we? This one, which has a shallow depth of field because the thing is focused here, In fact, I have since taken better photos. I need to update this page. My my Panasonic camera can do post focus, and it can do image stacking. So what it does in the camera is you focus on your target, and if you have it in the post focus mode or the image stacking mode, what it does is it then backs the focus off, so it brings the focus a bit closer, takes a photo, moves it, takes a photo, moves it, takes a photo, and I think by default it takes 10 photos. So it's bracketed on the focal length that of your object. So you then end up, and then it saves it as, what is it? I think it might be a motion JPEG or something. I can't remember. But basically it saves it like a mini movie, a 10-frame movie, which has the focus going through all of those distances. And then in the camera, you can specify, I want to be focused across this part of the image, and it then merges the photos together and gives you depth of field, which is really cool. So, yes. All right. I am going to go to lunch. As Peter reminded me, it is lunchtime. And now that Peter has told my stomach that it should be hungry, it is telling me that it should be hungry. So, Peter, it's your fault that I'm hungry. MP4 on the Panasonics. Yes, Joseph said MP4, Motion Picture Association format version 4. Post focus, Blackmagic. Yeah, post focus is really cool. So there are two different things. You can by taking multiple images and bracketing the focal length, you can do two different things. You can either do image stacking or you can do post focus. And post focus is really cool as well. That's when you can do things like take a photo of a person and there might be a background, like some building behind them, and you can tap on the person and they are in focus and the background goes out of focus, or you can tap on the, you can select the background and that goes into focus and then the person is out of focus, because the image is consisting of multiple frames and you can move the focus around within the image, and so you can play around with it and decide what you want your final result to be. So that's post focus. Focus stacking is when you have an image where part of it is further back than the other and you want all of it to be in focus, so the software collapses those images together and it blends them and uses the part of the image that is in focus for each area, and then you end up with a greater depth of field. Very, very cool stuff, and kind of confusing. But fun. All right. Joseph said, I've used FFmpeg to extract all the frames, then used Focus Merge in Affinity Studio. Yeah, cool. So you can do that. Depending on your camera system, you can either do the focusing, like you can do the processing in the camera. So on my camera, what I can do is open the image directly on the camera, and then on the touchscreen I can select the areas that I want to be in focus and hit save, and it then does all of the merging. It's got some built-in image processing chip in the camera, and it produces a single JPEG that comes out, which is the merged result of those frames. So, or you can take the MP4 out and then do it on your computer if that's what you prefer to do. So, there was another subject that I was thinking of getting into today. I'm going to tease you with it because this is something that I think warrants some homework, maybe, before next week when I might talk about it, which is coming legislation in Australia. Well, legislation's already been passed. The implementation is coming. It's coming into effect on July 1st, which will make it illegal to work as an engineer unless you have certain qualifications and have paid for a license. So it might be that I'm going to be out of business on July 1st. And that might sound like fear-mongering, but if you read it, like if you look at what it actually says, it's a pretty serious thing. So I'm not going to get into that anymore because I would really get in. That's a squirrel that I would chase. So, Sion said, what camera do I have? Is it a Lumix G7? No, it's a Lumix G85. So like the, what's the terminology? I think the G7 is like a semi-pro camera and the G85 is like a prosumer camera. So it's lower in the, Sion said, what type of engineer? Any type of engineer. Civil engineering, mechanical engineering, electrical engineering, fire. There are a certain number of categories. There is fire suppression, something engineering. It is illegal. It is going to be illegal to provide engineering advice or services. So, URL. Let's see if I can find this. In Victoria, in registration scheme. Yes, well, it was passed in 2019 and it is going to come into effect on July 1st this year. So it's called the Professional Engineers Registration Act 2019. So it comes into operation in only a couple of months. And if you provide professional engineering services, so in the areas of structural, civil, electrical, mechanical, and fire safety engineering, you will need to register. So you've got to be a registered engineer. And to become a registered professional engineer, you need a minimum of a 4-year degree plus 4 years working directly under the supervision of a registered engineer. So that's 8 years in order to become, in order to satisfy the requirements to be registered yourself. And if you don't meet that criteria, it is going to be illegal to provide engineering services in Victoria. Anyway, Sion said, you and I are going to have a lot of free time on our hands. Yeah, maybe it's time for a career change. Might have to move overseas if I want to keep doing stuff and charging money for it. Anyway, I don't want to get into that right now. That is a whole big thing. I'm probably going to talk about that soon. So in the meantime, have a great weekend. Thank you for coming along. And please let me know if you do see any implementations of the ESPFlash header, because the more I see of it, the happier I will be. And I will see you all soon. Thanks. Bye.